Hey everybody, welcome to Power Rule Part 3. I'm going to pick up where I left off in the other Power Rule videos, where we introduced this calculus trick here. Some function that looks like this, take its derivative, and it'll look like that. Why do we take derivatives in econ? Well, that's pretty easy. Anytime you want to calculate marginal utility, marginal cost, marginal revenue, marginal anything, that word marginal is econ speak for taking the derivative. Now, if there's only one variable in our function, only q, then you don't need this video. But if you have a function that's messier, say a production function like f of kl, and maybe it also has a form similar to this, like k to the alpha, l to the beta. So there's your Cobb-Douglas form. An example of this could be like 10 times k to the 0.4, l to the 0.6, something like that. We're going to use the power rule in this video to get marginal product of labor, marginal product of capital, and also get marginal rate of technical substitution to see how fast we are willing to trade off between capital and labor. So first of all, let's talk about what the MPL and the MPK are. MPK, marginal product of capital, is the derivative of f with respect to k. It is how fast production rises when you add more capital. Just like marginal utility is how much utility rises when you add one more thing. This is that, only with production and capital. One thing to notice is I wrote del's instead of d's. D's, like this, are for if there's only one variable, like in my G example up here. Del's, like this, are for if there's more than one variable and you have to pick one. Because what we're going to do is we're going to take the derivative of f with respect to k, and we're going to treat L here as if it's part of this M. We're going to hold it still and not let it wiggle. Let's talk about how we would do that. I can rewrite my f function, just rearrange it just for convenience's sake. A, L to the beta, K to the alpha. All of this stuff is the M, and this is my N. All right. So with that, my derivative, I can employ my power rule, and I'm going to take alpha by bringing my N down, multiply it by the M, and get k to the alpha minus 1. So notice I brought the N down in front, just like that's why the alpha is out front. I still have the A, L to the beta. K got to the -1. Yeah, it's all the same kind of thing. We're just treating L to the beta as a number. To go a little bit farther, what is it going to look like over here? 0.4 times 10 is 4. L to the 0.6. K to the -0.6. That's my MPK. So let's talk about my MPL now. Well, this is del F, del L. And in a similar manner, I'm going to hold K to the alpha as constant. And so my M is going to change a bit. My M now is all of this. Is that AK to the alpha. And so when I take the derivative, I'm going to put beta out in front of it because the exponent comes down. AK to the alpha. So there's my N times M times L to the beta minus 1, which in the example is, let's see, 6 times L to the negative 0.4 K to the 0.4. Cool. And with that, we've got MPL and MPK. So this was F, this was MPK, this was MPL. The last thing I want to show you in this video is the marginal rate of technical substitution, which is just MPK over MPL. No calculus here, just algebra. In the case of my marginal product of capital and my marginal product of labor, I'm going to be lazy real quick. I'm just going to, there's MPK, there's MPL. Now, how does that simplify? It simplifies greatly to just alpha L over beta K. How does that come out in green? That's going to come out as being 2L over 3K. So, I hope that this was useful to you. If not, you know, well, too bad. Good luck, you guys. And yeah, thanks for watching. See you next time.